It should work now.
Yeah. Okay. Hello, everyone. Welcome to the New Year, New DAG Lecture. Today we have Merel Penterman from Archol, who's going to be sharing her master's work, right? And I think that's all. So take that away.
That's it.
Thank you.
Yeah. I think the audio is on now, so I hope everyone online can hear me and see me as well. Thank you all for letting me be here. I'm glad you are here. I was a little worried no one would show up, so this is great. Today we'll be talking about ancient storage and AI. As already introduced, this is my research master's topic a little over a year ago. Just to quickly, should I click? Yeah, quickly introduce myself. Who am I? You probably do not recognize my face because it's been a while. But I did my research master's thesis a year ago. I finished it a year ago. Here at Leiden, I did digital archaeology. I did it with Carsten Lambers, who you probably most of you know, of course. And I've also been working as a field archaeologist and digital archaeologist for Archol as well. So that is the company, the commercial company that is within the faculty. And it's quite a unique position to have because I've been doing a lot of field archaeology, excavating Dutch commercial archaeology, which is a very unique world. And with that, I've also been able to combine digital methodologies and digital research right now at Archol, which is pretty great. So it's quite a unique perspective, I think, in this case. And I wanted to mention this because I want to outline what I'm talking about when I talk about archaeology. When I talk about archaeologist or about prehistory, I'm talking about Dutch commercial archaeology. Just so you know, I don't want to generalize all of archaeology. It's really, my frame of reference is Dutch commercial archaeology in this case. So thank you that I can be here. I'm really honored. It's the first time actually I'm presenting my research to digital communities. I'm quite excited to hear what you think about it. And I want to delve in immediately with one of my research questions, if not the research questions. And that is actually what I did is, can deep learning help archaeologists automatically detect prehistoric granaries on excavation GIS maps? And if so, what does that mean for archaeological practice? And as you can see, I divided it into two topics. So the first one was making a model. Is it possible to make a model with this idea in mind? But also, if we have such a model, how can we implement it within the archaeological workflow, in this case, the Dutch commercial archaeology workflow? Can we, and if this model doesn't work, what does it need in order to be able to work within this workflow? It's very easy setup. It's just my thesis. I will go from beginning to end. As I said, there are two parts within my thesis. One is the model. I will focus predominantly on that today, but I've also had a lot of chapters about what this model will do to archaeology, but that is too big a topic for these 45 minutes. So I will focus mainly on the model in this case. So my methodology, the data set, results, and especially the discussion and a lot of mistakes that I made during this progress. So first to introduce my topic, and I think this is more of a universal problem. In archaeology, we have a lot of complex excavations. Archaeology in general is very complex. So we have a lot of different stratigraphies, we have different periods overlining each other, different structures that overline across each other. So it's also very difficult to look at archaeological record and see what is actually going on there. So it's very complex. And a lot of colleagues from mine, a lot of co-workers, they are very frustrated when you have these kinds of excavations because you have hundreds, if not thousands of postals that we cannot structurize or make some kind of disentangle them from all that is happening within such an excavation. So I thought, with my research master in mind, let's try to make an AI model that is able to look at this data set and perhaps make some interpretations out of it. Look at structures, basically. And just for people who don't really know, archaeology, of course, has undergone a large methodological shift. We have a lot of big data lately. It's not big data in the sense that you have in other disciplines. It's a bit smaller, but still for us, relatively, we have a lot of big data as of late. And deep learning, of course, has already been successfully implemented. But also when I started doing my research, the project here at Leiden, so the PhD project, regarding the LiDAR data and the burial mounds that they found on those LiDAR data sets with automated detection was already there. So I had a ground plan already in place. I want to mention this research because I use a lot of the research in my own research. It was really like a foundation for me, like a methodological workflow that I could look at. It's really great. It was very successful. And it really started this AI research within large excavation datasets. However, when I started, and I'm not sure if that's still the case, GIS data, so excavation data, remained untouched. So no one used it yet. Maybe that's changed, but I've not really seen the literature as of late. But I thought, let's try it. This is also a lot of data that we have out there, a research problem that I just outlined. And I thought, who knows, maybe AI can help us here as well. Well, there's good reasons why we don't use GIS data. It's actually not quite ideal. Of course, we have less data than when you have larger data sets. When you have, for instance, LiDAR data sets, they're way larger. They are standardized oftentimes. They are in one format, one frame. They're quite raw most of the time, whereas GIS data sets are not. They have been interpreted, reinterpreted. Measuring with the GPS is also something that archaeologists interpret at that time, whether they should measure something or they should not measure something. So it's not raw data at all. It's very interpreted. It's also very fragmented. It's very incomplete. So all in all, it's not very ideal data for AI. Still, I wanted to try, and that was also the idea behind my research, was to see whether it is possible at all, if it would make any conclusions at all. That's why I tried it. Just to give you an overview of what I mean by these GIS excavation data sets, these are the ASCA's that we create in commercial archaeology. And ASCA is short for alle sporenkaart, which is in English is all feature maps. So literally all the features together in a map that is created to be visually pleasing to the eye. So it's also, again, interpreted, it's changed, it's altered. And as you can see, just to outline the problem a little bit, what I'm talking about is that there are three structures very clearly visible here. We did this last year in Apeldoorn, this excavation. I was there myself, actually measured this myself and made this map myself. And as you can see, these three are very clear. We opened the trench and we're like, yes, we have a house plan. Yes, we have a granary. This is actually a medieval granary. They're different to what I'm going to talk about next, but still. But when you look at the northern part, it actually illustrates a bit of what I'm trying to say. These are dozens of post holes that they don't make sense. We weren't able to make a house plan of it. We weren't able to structurize it in any way. It can have multiple reasons. Of course, maybe the structure is not there. That could also be the case. But also by looking at it for hours, we have not been able to see anything in this. So I thought maybe AI might be helpful in this case. And this is just a small example, one off the top of my head. There are examples of larger excavations with thousands of these post holes everywhere scattered without any structure whatsoever. Just to give you a pretty picture of that actual excavation that we did with drones, so you can see the house plan here, which was, I just like this picture, so I'd like to show it, which was right over there. And the speaker or the granary is over there in the corner. And that cluster of post holes is right there in the north. It was a great excavation. It was very beautiful though. But well, I was thinking I can do all house plans, but then I'll be here for the next 20 years. I mean, we have so much typology, so many typologies within archaeology, especially also in Dutch archaeology. The house plan typology book for the Netherlands is this thick, so it was impossible to gather that data, to label all that data, to make all these different categories for all these different typologies. So I needed to have a case study. And quite soon I came on granaries. In Dutch, they're called speakers, which is quite a weird name, but it is a granary. And in general, for people who don't know, these are small raised structures. You can see an example on the right of how they might look like. They're associated in the Netherlands predominantly with Bronze and Iron Age settlements. They're interpreted as facilities for storing crops or food surplus. they help to protect actually the contents from moisture and pests. So it's quite logical. It's a raised platform, so the moisture doesn't get there as easily as it does when it is on the ground. They're always wooden structures. That wood is oftentimes rotten or not preserved, so you're left with a post hole or ditch, which we can see on excavation maps in these structured ways. They're actually very standardized, remarkably standardized over the course of these two periods. So in the Bronze and Iron Age, they hardly ever changed their typology to anything different than these two, these five, I think. And most predominantly, we have 4-post speakers or granaries, 6-post and 9-post. Those are the ones that are most dominant within the archaeological record. Especially the 4-post one, we have about 80% of all the granaries in the Netherlands are 4-post granaries. So they're very standardized, they're very easy to recognize. And they're often found within settlement zones, but also in significant numbers. So you have one house plan, and it's very common to find a few dozen granaries surrounding that house plan. So you could have 40 per house plan, for instance. But it depends on whether they were used consecutively or in different phases. It's very difficult to research that as well. And to just emphasize is that there's actually hardly any research done on them at all. In my entire thesis, and I've done this for 2 years, and I've looked very hard, I found, I think, 6 papers in total. One of those was a really big and good paper, and the 5 others were small subchapters in a larger book that just talked about granaries a little bit. So it's very understudied. And the only way that we look or that we identify granaries is by the pattern and similarity of the post holes. So when we see this pattern as an archaeologist, that is enough for us to say this is a granary. We don't need any more evidence, which is actually, in my opinion, quite little evidence. I'd say maybe too little even, but that is enough in general for the Dutch archaeologists to say this is a granary. When post holes are missing, so if you have a 6-post granary, for instance, like here, and one of these is missing, some archaeologists say this is a granary, others say it's not. So it depends on who you ask, whether they would define it as a granary or not. So it's really actually quite arbitrary into the data, what is a granary or what is not. Of course, you'd say botanical research is a good marker for whether it's a granary or not, but it's hardly ever done. It's not deemed necessary oftentimes. They've done it sometimes it's been conclusive. So they've actually argued for, I think, 3 or 4 granaries in total that they've actually been used for grain storage due to a large amount of grains within the post holes or something else. But in general, it's not conducted. And if it's conducted, it's inconclusive. So they find 2 or 3 grains. Yeah, could have been a granary. We don't know. So I'd just like to highlight this to show you that the data at the start is already very, very, very arbitrary. And it's also that the whole black box issue that we've been talking about within AI, it's already very apparent within the human black box issue that we talk about when looking at archaeology in general. So not much is needed to say this is a granary or not. Actually, too little, in my opinion. But still, people do it. They identify 40 granaries in one excavation based upon simply the outline of this 4 posts. Generally, these are also 2 meters apart, so that's quite standard as well. So it's a great case study because they're frequent and they're quite standardized, but there still is a lot of arbitrariness going on. So my data set was difficult to find. I eventually looked at 19 excavations and I was able to pinpoint 477 granaries, which is not a lot. You'd wish to have a lot more, but I've been searching for weeks and I couldn't find any more. So this is what I had to do my research with. And as you can see, the difference in the amount of post holes is quite similar to the archaeological record. So 80% was 4 posts and then a little less when you go further up. I completely ignored the 8 or 5 post one. So you have 2 ones here. because there were 2 or 3 examples in the entire dataset, and I thought that was too little. So I completely focused on these 3. So the data that we have is a GPS data in a shapefile. It's quite easy. And the shapefiles are linked in this case to a database containing a lot of metadata. And this is how Dutch archaeology does it in general. I think a lot of archaeology in the world does it like this. So you have a database that has a primary key of the feature number, which has connected metadata to it, which is quite extensive. This is just an example to show you how one of the tables looks like, but there are 20 tables with all kinds of data connected to these features. So we're talking about color, texture, depth of the feature, find numbers associated with it, everything that you can imagine. And this data is that ASCA that I talked about, so that's all feature map. Another example again here. So this is the Apeldoorn one, which already has a layout. And this is more a raw version of these alle sporenkaarten in Dutch. It's a really weird name actually, but so. And this is also actually an example that I used for my data set. As you can see, there's a beautiful 9-post granary here in the corner. So I used this as one of the labeled instances. Yeah, so on my methodology, I don't want to make it too technical, so I'll keep a little, also for my own sake, because I'm not really good at explaining that. But I used object detection, and maybe some of you already know, there's a difference between classification and object detection. Classification is quite simple. It just says there is a cat in this picture. So in this case, it would say there's a granary, or there's a 4-post granary in this picture. But I wanted, of course, to have the location, and then you use object detection. And object detection just makes a bounding box around your identified object, and it says what it is. So that's the main difference between these two. So I used object detection. So the algorithm would tell me what the object is and also where it is located. I used YOLO version 8, which is a great name. It's not you only live once, it's you only look once. It's not that old. I think it was invented between brackets in 2020, so it's quite recent. Prior to that, we used CNN or faster RCNN, which is another flavor of algorithm. And that's also the algorithm that has been used in the example of the burial mounds. They used the faster RCNN algorithm. But actually, YOLO came out when I was doing my thesis, and Professor Lambers told me this might be perfect because it's way more lightweight. It's easier to implement. Where CNN are in general 2-stage detectors, so they iterate 2 times over your data. You only look once, that is the name, is a 1-stage detector. So it does it all in one go. So it predicts the bounding boxes as well as the class labels in one single pass. That makes it less heavy, so you need less computational power, which is ideal, because I also wanted to make it useful for general archaeologists in the field who don't have very good laptops out there. So this was a more a balance between performance and speed, in my opinion. And I also thought, yeah, it's not a life or death situation. I don't need to have the best model out there. So this was, in my opinion, the best fast, but also still quite accurate model, which was available at the time. I'm not sure if it's still version 8. It might be version 20. I don't know. Because like 3 versions came out during my thesis, so I had to change up. You probably know the issue. I had to change my model each time. Still, YOLO is not a bad model. It's just a bit less accurate than CNNs are in general. So CNNs are still used for medicine and healthcare, so things that you really need accuracy. But in this case, I thought it was sufficient enough. Yes, and then you have data. I did a lot of data pre-processing. I will highlight that later, maybe a bit too much. I wanted to create maps that were easy to recognize for the algorithm later on, but I'll explain later. I did that too much, so I didn't create good environments for it. So it was no longer usable in real life situations. So that was my issue, my mistake. But I cleaned the data by first of all making it black and white. Color is not relevant, of course. Color is something that we add to a map. In this case, I'm really looking at the shapes of the granaries in this case. So you can see the similar images. So these are the similar maps, but I removed all recent disturbances. I removed natural features. And actually, yeah, all other things that I didn't deem very relevant for this research, but also things like section lines and trench lines and all that noise I removed because that I didn't deem it as relevant. Because these are, for example, all recent disturbances, these black lines. I think they are recent ditches or something. Then I had to make pictures. YOLO needs 640 times 640 pixels as an input data. So I created pictures using GIS of all the speakers, for granaries in this case. Then I did some data augmentation because, as you might already have seen, I have very little data. So I tried to augment it by creating different pictures from the same pictures in order to make more data. That was basically the idea. It's a very often used technique within AI research to augment your data. And the way it looks like is this. So you have an original image right there, and on the other one. And then you augment it by cropping, by turning and twisting it around, by pulling at it, and doing that just enough so it creates new images, so new training data sets. It's not ideal. You, of course, want new actual images, but this is like a way to work around the fact if you don't have enough data. So this was basically my alternative. As you can see, these are the granaries that I'm talking about in this case. After you have the data augmentation, you need to label them, of course. It was a lot of work, a lot of work. I had to manually label, of course, all the granaries like this. And eventually I had a total of 1,201 images, which is not equal to the amount of granaries because some images have multiple granaries, of course, as you can see here. I also did the overlapping to make sure that the model could also try and understand that. And eventually I had 620 successfully labeled instances, so labeled like these. 450 negative examples. So these were, due to the data augmentation, sometimes the granary fell off the screen. So I had examples where nothing was in there. So that was a perfect negative example. There is no granary here. And I had to exclude 130 images due to just either them being completely empty or completely black, or just cases that I think this is not useful in this case for the research. So it's not a total of 1,201, it was 1,070. So this has to be subtracted from it, which is still not a lot of data, but it is a lot more than it was. So I thought, yeah, we'll have to do it with that for now. And then I chose a model. I'm going through it step by step. It's very interesting. So I used the YOLO V8S model, which is the second smallest model that's out there. You have a nano model as well, which is really small. That was too small in my opinion, but if you go larger than the S, it's more used for data sets of thousands, 10,000, millions images, and that's just not the case here, so I didn't deem it necessary to use a larger model than this. Furthermore, it was transfer learned on the COCO dataset. Probably people know about it. It actually means that the algorithm isn't completely empty. It already knows some stuff because it's already pre-trained on other images. And in this case, the COCO dataset is really toothbrush, spoon, like those basic objects that it's already trained on. And it's quite a common way of training your transfer learning or pre-training your algorithm to make it not start at zero. And then I trained 3 models just because I wanted to play with all the parameters. And for the case of, to keep it not too complex, I just wanted to talk about model 3 because that eventually was the best model. So I'm not going to talk too much about this, but what I do want to mention was that I try to prioritize recall over precision. And that is what we often see within archaeological AI research, because I don't know if you know the difference, but precision is basically of all the times the model says, here is a granary, how often it's right. And recall is of all the granaries within the datasets, how many times was it able to recognize one. And in my opinion, and I think in most archaeologists' opinion, recall is more important because it's okay if it shows us a wrong picture, but it's less okay if it doesn't show us a picture at all. So if you miss granaries, because I can quite easily say, oh no, this is not a granary, you throw it away. Whereas I really wanted it to show all the granaries within the data set. Therefore, you generally do a lower confidence threshold and a lower IOU threshold, so intersection over union thresholds, which basically means it's less strict on showing you the examples that it might think that are granaries. So sometimes it's not really sure. It has a confidence threshold of 30%. It might, 30%, maybe I will not show you. When you do a lower threshold, it will show you these instances. So it will show you more options. And as you can see, they're quite low. Generally, you do these a bit higher. I also played around with them. So I started at 20, which is really low. It showed me so many examples. It was not doable. So eventually I went to 40, which was way better. So eventually this model was the best performing model overall. Yeah, the RU threshold is more the overlap. So of how much does the bounding box needs to be over the original bounding box in order to be correct, so to be deemed a correct prediction, as you can see here in the image. So that's what I wanted to achieve. So I really looked at that, at ways to make recall higher. You'll see it didn't work out, but I tried. And then eventually I trained the model. And that was just in the regular way that we do things. You do an 80-20% split between the test and training set. So that means that 80% of the data is used for training and 20% of the data was used for testing. And that's quite regular methodology that we use. So as you can see here, I had 856 for training and 214 for testing. Total of 1,070. Still not a lot of data, but it's all I had in this case. And here are the actual results of model 3. So all the models were a bit different, but this one was the best performing model. So you have precision, recall, and the mean average precision. A mean average precision is basically an average between the precision and recall across categories on how it really performs on average. So it's like a basic global idea for you of how your model is performing. It looks great. It looks a bit too great, to be honest, especially when you look at granary 9, so the class of 9 post granaries. It had a recall of 1, which means that it was able to detect all the granaries, but at quite low precision. So it was also pointing at things. This is a 9 post granary when it was not. Well, this is basically due to the amount of granaries of 9 posts I had within my data set. This is not good at all. It's overfitted. It knows too well how it looks like within the data set, but when I put it onto anything else, it will be completely wrong. So this actually just dropped this category within my evaluation metrics because this is not, this should not happen. This is too good. And I think within the testing set, there were like 7 examples. So that's way too little to accurately assess whether it is working or not. But the other categories had way more. So there were like a few hundred in both categories in this case. And this is a bit better than average on what it was doing. So it had a precision of about 90%, which is actually quite good. So it was able in 90% of the instances, and I think it's summarized it here. Yeah, it was able to be 90% of the cases to be correct. So if it pointed at something, 90% of the time it was correct. 10% of the time it was wrong. But the recall was actually very low, which was surprising to me because, as I just mentioned, I tried to make the recall quite high, higher at least. But I think 66% is too low, in my opinion, because that means that 34% of all the granaries in the datasets were not recognized at all, which I don't think is usable within archaeology at all. So that was quite surprising for me, actually. And these are some examples of the output that it did. So it shows you a bounding box and it shows you the confidence of the algorithm for this particular instance. So in this case, at the bottom left, you can see that it was 80% confident that it was a 4-post granary. And these are just some examples. So I have these pictures of all the granaries, of all the pictures. But as you can see, something, this is going good. It's 100% certain, 100%. It shouldn't happen. And I think, oh, I have it here. There were some things happening in the data set as well. As you can see, that one is correct. That is clearly a granary. Also, when I looked at the data later on, because I, of course, know where the granaries are, this is a granary. But on the right, you can see, maybe you can recognize already a bit, that's a house plan. So houseplants look apparently quite similar to granaries. So all the houseplants within my dataset were identified as being multiple granaries stacked on top of each other, which is not correct. So many of the mistakes that it made was actually due to these houseplants. Another thing that happened quite often was this, is that it's identified 2 granaries where it should be 1. So it had a granary category 9, is of course also a 6-post granary. The same happens for 4 and 6 sometimes here as well. So it sees a 4 and a 6 in one granary, which is problematic, of course. And I think that's mistake number 1 that I made. And that was something in hindsight, and I discussed it with Professor Lammers as well. And he was like, yeah, we shouldn't have done this. We shouldn't have done the labeling categories. You think when you start out making a model that these categories are useful because you want to differentiate between multiple categories. But actually, when you think about it, granaries are quite similar in how they look. They're quite rectangular or square. And one class would have been sufficient. So if we would have just, or I would have just used one granary class, it would have actually been better for the entire research. Because also what happens is when you split these in different categories, your training data is also split up into these classes. So it makes the small data set actually even smaller because you split it up in 3 different sections, whereas you actually want to have all your data on one big heap or one big pile, and instead you make it even smaller. So it has less examples to train on when instead if you put it on one pile, it would have had more examples. So that was a big mistake, and I think if I didn't do this, I didn't have time to correct it, unfortunately, but the model would be way better. But that's conjecture, I'm not sure, of course. So I possibly made it worse by using these categories, and actually categories, when you think about it, they're not really useful. When it just points at a granary, I can count myself if it's a 9-post or a 6-post or a 4-post. It actually doesn't do much. It just shows me it's a granary, and that's fine. So that was mistake number 1, more to come. It also would have made room maybe for future for more classes. So if I would have included house plans, maybe it would have been able to not make this mistake, or at least make this mistake less than it did right now, because now it doesn't know what a house plan is, of course. So that's something to think about. And that's also a lot of the mistakes were coming from this labeling class mistake. So I really think if I didn't do this, it would have been way better. Mistake number 2 was cleaning the data too much. That was mainly inexperience from my part. I had never worked with deep learning before. I'm an archaeologist, it was all new to me. So I was thinking I should make my data clean, pre-process it, make sure that the model can understand it. But of course, your data is never clean, especially when you use it in real-life examples. So I inadvertently made the model worse, actually, for real-life applications. Now, when I think about it, it's really logical, but I didn't do that. So when I used my model on these problematic excavations that I talked about earlier, this is one example. I think this is Schipluiden's notorious Dutch excavation where they found thousands of postals and no structures at all. It doesn't work. I mean, it sees a lot, and especially if you zoom in and out, it will see it's a mess. It will see thousands of granaries everywhere, and that's simply because it isn't equipped to handle messier data. As you can see, maybe from my examples, these are very clean, very organized pictures. There are messier ones than these. These are the pretty ones to show you, but yeah, they're not real life examples. So that's a mistake I made as well. But still, I was the first one to try this, so that's, yeah, I should have maybe not at all cleaned my data, just put it in raw and see what happens. So I think the model would be better equipped to handle messy situations as it isn't completely right now. And the last mistake I made, and that was apparently transfer learning on the COCO dataset is with recent research, also from Wouter, from here, is not actually good for your model. The COCO dataset looks like this. It's very different. It has color, so it has RGB color. It has way different classes, way different shapes, sizes, different things to look at. And when Wouter tested this transfer learning on a model, a clean model, and looked how it worked, and with a non-transfer learned model, there was a significant difference in how good they were. So the not training it on the COCO dataset would have actually been better. I just thought this is something you do because everyone does it on all the automated detection algorithms. So I thought I should do it as well. But apparently it is right now known that that's not actually helpful at all. Of course, transfer learning on a model with similar data, so black and white dots on a map, would have been good. However, there's no model out there, at least not, I don't know, maybe now, but there wasn't when I was doing this. So it did or does not exist. But that's apparently has a significant implication in the model as well. I'm not sure about the numbers or how well it would perform if I did not do this, but at least it would have improved something within the model. It wasn't all wrong. I actually, and I'm not sure, because again, what granaries are is quite subjective and arbitrary. But when looking at the false positive, of course, so when it points you to something that is a granary, but according to your dataset isn't, it's not always the case that it's wrong, but because it could also be new granaries. And I think in these instances, when looking at pictures and the metadata and everything around it, I think these are just a small example. I think I had about 20 new possible granaries. Well, it's impossible to verify now, of course, but possible new granaries that are actually here. And this one is really cool. Apparently these were, the dataset, it was a 6-post granary, but I think what it says here that it's also a 4-post granary might be correct, because these were actually probably reused. So they made a 4-post granary and later on reused that and made a 6-post granary, as these are double post holes that are actually fitted together. So you can see the phasing within the post holes, which is really cool. So that could actually be a new granary that could have been found. And these others as well. These are a little atypical. So they could also be not granaries, but they were very similar in dating. These all had similar pottery and shirt depositions within them, but the spacing is a bit off. But still, again, when is a granary? It's still quite uncertain. I have no clue how fast I'm going. Oh, it's not that bad. Okay, cool. So just to wrap it up a bit, can this be used? No. As I said, I made a lot of mistakes. Too many mistakes. It was inexperience from my part. Also, no one had ever done it before, so I had no clue where to begin and where to end. But I do think I was able to outline with my thesis what is necessary to actually develop such a model and to make it useful within archaeology. Right now, there are too many mistakes, too many biases. We should really think about what constitutes a granary, because right now it's too uncertain. So there's also no way to check whether something is a granary or not. The performance metrics in general are good, quite all right. And with improvements, I think a hypothetical future model with way more data than this could actually be an adequate model to use practically. And I'm not saying, and I know you've heard it before, I'm not saying as a replacement of the archaeologist, of course. This is more as a tool that we could use to pinpoint us to possible locations for, in this case, granaries, but we also could use it for other house plans or other structures that come to mind. But it's very difficult to assess when it's adequate enough. Of course, some people are very wary of AI and will not use it. I think the younger generation is a bit more accepting of AI. And it's, of course, more than just high precision and high recall, because as I showed you, these metrics don't say much over actual practical use. It should be able to generalize across different sites. It should be versatile in handling different types of data sets. And it should also be a meaningful contribution. So it should add things. It should aid us in helping with our interpretation and with our workflow. So something to think about. So we need more and more data. And it's just not there yet. It's not standardized. It's very difficult to find. So there should be a way to get this somewhere. But that's life's work if someone wants to do that. And with that, I think recall would be improved if you have more data. And also if you fix my mistakes. And also something that I wrote a whole chapter in this, but I'm currently just looking at 2D images of black dots on a map. It's not a granary. They're not similar. Granaries, as I said, are quite complex. They're much more to what a granary is. So adding more data, ideally, like metadata, but also domain knowledge, expert knowledge, and all sorts of things that you can think about would, of course, make this a way more holistic algorithm. Right now, it's just really looking at dots on a map, which is, of course, not equal to this is a granary or not. But still, I think it's a good start, that it's possible in a sense. And just to conclude, I think it has potential. I think it will take another few decades before this actually works. But it is something that we can think about. More research, of course, into granaries, but also into other structures should be there, because right now it's just not clear. It also it's not just granaries, other house plans as well. We don't often know why this is a house plan. It's oftentimes just because I think so. And that's very difficult to get that into a model. So that whole black box issue, and I think Professor Lammers also emphasized that quite a lot in his talks and in his research as well, is that there is also that human black box issue that we should think about, from why do we categorize certain elements into certain typologies? And is that really the way to do it? And I think AI research is therefore not only methodologically interesting, but also more theoretically and critically interesting, because it also reflects on how we categorize certain elements within our archaeological record. And I think we're oftentimes very wrong, especially with granaries. I was surprised how little people care about, oh yeah, it looks like one, it's one, which is, it's not horrible, but it's not, it should be done differently, of course. So that's what I did in a very short time. And I think that concludes what I wanted to say to you. Thank you. My thesis can be found as well if you want to read it, but it's a work. So thank you.